Hello and welcome to another GCSE revision video, and in this video we're looking at the AQA GCSE 8300 series. This is the second paper in the higher tier. It's the November 2017 past papers. It is a calculator paper, so we are allowed to use calculators. And we're picking up in question 15, which reads, Mirek invests £6,000 at a compound interest rate of 1.5% per year. He wants to earn more than £1,000 interest. Work out the least time in whole years that this will take. Okay, it's tempting at this point just to panic and go, what was my compound interest rate? P equals something to do with R, I can't remember. Don't worry, we can work this out from first principles just from our knowledge of percentages. So let's say in year one, he invests his £6,000. So at the end of year one, he has £6,000, which is his original investment, plus 6,000 times 1.5%. So it's 1.5 divided by 100, because percent means divided by 100. So he's got his £6,000 plus his interest, which is 6,000 times 1.5. Okay, so in year two, he's going to have his £6,000 plus his 6,000 times 1.15 over 100. And all of that, he's going to have his interest on top of that, which is basically this lot multiplied by 1.5 over 100. So what we can do is if we factor out the 6,000s just to make life easier, we can say year one is actually £6,000 into, so 6,000 divided by 6,000 is 1, plus 6,000 times 1.5 over 100 is just 1.5 over 100, and 1.5 over 100 we just move the decimal points 2 places to the left, so that's 0.015. So year one is actually 1.015 times 6,000. Now, what's going to happen in year two? Well, year two is basically going to be the total amount for year one plus the interest at 15%, which is going to be 1.015 times everything in year one. So it's 1.015 times all of this. So in other words, it's 1.015 times 1.015 times 6,000. Hang on, I'm seeing a pattern develop here. So year three is going to be 1.015 times 1.015 times 1.015 times 6,000. In other words, year three is equal to 1.015 raised to the power of 3 times 6,000. So we can generalize this and say year n is equal to 6,000 times 1.015 raised to the power of n. And that is our compound interest formula that we've just derived from first principles. Okay, calculator time. So let's just try some trial and error guesswork. So we've got 6,000 times 1.015 raised to the power of, let's guess, say 5 years, why not? And that's equal to £6,463.70. What value are we looking for? He wants £1,000 interest. He started with 6,000, so we're looking for £7,000. So after 5 years, he's nearly halfway there. So as a guess, why don't we try 10 years? So 6,000 times 1.015 raised to the power of 10. £6,963.25, almost. So let's have one more year, and let's make that 11 years. So let's try 6,000 times 1.015 raised to the power of 11. £7,067.69. So 10 years is not enough, but 11 years is just a little bit too much. But to the nearest whole year, it's going to take 11 years. Okay, so that's one way to do it. If you stick around, I'm actually going to show you a little bit of a crafty way to get to that 11 years really quickly. Have you ever wondered what the log function does on your calculator? If I say take 10 raised to the power of, say, 8, that's 100 million, and then I find the log of that, I get 8. If I say 10 to the power 7, and I find the log of that, I get 7. So what the log does, if you take 10 to the power of x, and you find the log of 10 to the power x, it will give you x. Now here's something really clever. If you have 2 to the power x, you can't just take the log of 2 to the power x to get x. You get something completely different. But if you take log of 2 to the power x and you divide that by log of 2, it will give you your x. In fact, if you take any number a to the power x and you take the log of a to the power x and divide it by the log of a, where a is the base that you raise the power to, it'll give you back your x. Okay, well that's all very interesting, but how does that help me get the 11 years? Well, if I know that £7,000 is the number I'm looking for, is equal to £6,000 times 1.015 raised to the power of n, where n is the number of years, and I want to know how many years that is. If I divide both sides of the equation by 6,000, I'm going to get 7,000 over 6,000 is equal to 1.015 raised to the power n, and these zeros all cancel out, so it's just 7 over 6. So I've got 7 over 6 is equal to 1.015 to the power n, and we know somewhat clever we can do with logs now, don't we? So if I say that the log of 7 over 6 divided by the log of 1.015, that's going to get me equal to our n. So let me grab my calculator and check this out for clever. So if I go 7 divided by 6 equals, and then divide by, 7 divided by 6 equals log, and then divide by 1.015 log, and equals 10.35. So I need 10.35 years, which 10 is not enough, and 11 will be a little bit too much. So I can get straight to my 11 without having to go through all that guesswork. Okay, I hope you found that helpful. If you're taking your GCSEs this year, I'd like to wish you every success with your revision and every success with your exams, and I'll look forward to seeing you in another video.